In this example, you're asked to solve the equation cosine squared theta minus 3 cosine theta minus 2 equals 0 if theta is between 0 and 360 degrees. So the first thing we might do is substitute, as we did in a previous example. We could let u be a stand-in for cosine theta. And the reason we might do this is if we recognize that this thing has the form of a quadratic equation. You've got a squared term and then cosine to the first and then a constant. Doing this substitution is not required, but it might make, if you're having a hard time with these, it might make the problem a little easier to look at. So that the cosine squared theta here becomes u squared, since we're replacing cosine theta with u. And then minus 3, there's a cosine theta, so we replace that with u. Minus 2 equals 0. Okay, and then we might think about trying to factor this thing. If you're going to factor it, then you need two numbers whose product is negative 2. So you multiply to get negative 2. That's got to be, if we're using only integers, 1 times negative 2 or negative 1 times positive 2. That's the only way we can multiply to get negative 2. But the numbers need to add up to negative 3, and that just doesn't quite work. We would need both 1 and 2 to be negative if it's going to add up to negative 3, but then when you multiply two negatives, you get a positive. So this is one of those quadratic equations where it really looks like it should factor, but it doesn't, which means we need to use the quadratic formula. Got an extra letter there, sorry about that. This is supposed to say quadratic. I know my handwriting's never great in these videos. Sorry about that. Okay, so, and we're solving for u, let's be clear here. So u, which is a stand-in for cosine theta, is equal to opposite of b, so that's opposite of this value would be positive 3, plus or minus the square root of b squared, which would be that negative 3 squared, minus 4 times a, which is the coefficient out front, that's 1. 4 times a, which is 1, times c, which is negative 2. So I'm not going to even bother writing the 1. It's negative 2 here. All divided by 2 times a, which is 1. Okay, so if we simplify that, we have 3 plus or minus the square root of 9. And then when we multiply here, we have negative 8, but with the negative in front, this is positive 8. So 9 plus 8, all divided by 2. So this is 3 plus or minus the square root of 17. If you apply the quadratic formula, once you see something like the square root of 17 or the square root of a negative, then you know that it was never going to factor using integers, and you were right to go to the quadratic formula. Sometimes you apply the quadratic formula and you end up with something like 3 plus or minus 1 over 2, and then you've got to kind of slap your forehead. No, well, I could have factored that if you end up with something of this form where it's going to give you these nice rational numbers. But not in this case. We were correct that quadratic formula was really the only way to go. I don't know why I'm erasing this. I'm trying to get... Anyway. Okay, so these are definitely not values that you're going to get straight off the unit circle, 3 plus or minus the square root of 17 over 2. So we should use a calculator to approximate them. And I guess I'll do that on a clean page here. Okay, so we've got, where are we here? Yeah, and see, sometimes when I change pages, for some reason the pen just randomly gets thicker. Okay, u, which is equal to cosine theta, this might be a little too thin, is equal to either 3 plus the square root of 17 over 2 or 3 minus the square root of 17 over 2. So 3 plus the square root of 17, if you enter that in the calculator, and when you do enter it in the calculator, make sure you put parentheses around the numerator in each of these. But you should get 3.5616 over here. And negative 0.5616 over here. Now, a couple of things. Remember that cosine only reaches values between -1 and 1. I like to explain that using the graph. So the graph of y equals cosine theta stays between +1 and -1. 3.5616 is way up here. And the graph just never reaches that. This is not a solution, since it's not between -1 and 1. That's the range of cosine theta. It will reach that second value, so the negative 0.5616. And in fact, if you think about the unit circle, covering values between 0 degrees and then one lap all the way around 360 degrees, negative 0.5, so that's about here, right? Here's this negative 0.5616. And so we should find two solutions, one in quadrant 2 and another solution somewhere in quadrant 3. So we are expecting two solutions. And now it's just a matter of finding them. Okay, so here we are at this point. We know that we want to find a theta such that cosine theta is equal to that negative 0.5616, because that's what came from our u substitution, which replaces cosine theta, and then applying the quadratic formula. So one thing we could do that will at least give us information about the reference angle, so that's why I'm putting a little theta hat on it for the reference angle. We could take inverse cosine of negative 0.5616. So if you grab your calculator, make sure you're in degree mode, and enter that, you should get about 124.2 degrees. And there is one of our solutions. That would be the quadrant 2 solution, because that's between 90 degrees here and 180 degrees here. Okay, so there's one of our solutions, but we know that there's another one in quadrant 3. To find the quadrant 3, so you could use reference angles. I'm just going to draw a little picture here. So now we know that this angle is 124.2 degrees. The quadrant 3 solution is going to be this solution right here, where this angle is 124.2, because it's going to be the mirror image of that quadrant 2 solution. We just want the mirror image down in quadrant 3. Okay, but that's actually negative. I mean, if we measure it this way, that's actually negative 124.2 degrees. And that is a solution. I mean, but the thing is that we're asked for solutions between 0 and 360 degrees. So this is less than 0. If we want a coterminal angle, I'm just going to write coterminal angle, we can add a full rotation, so add 360 degrees. That'll take us all the way around this way to the angle that also lies right here. If you do that, so grab your calculator again, or do some arithmetic on your paper. That's one where you could do. But you'll get 235.8 degrees, and there is the quadrant 3 solution. And so those are the two solutions to this equation.